Hello, and today I'll be demonstrating how my final project works. This project tracks how many times a litter box was used in the span of 12 hours, and then every day at 9 a.m. and 9 p.m. it sends an email telling how many times the litter box was used. This is done because there is under it is on the load cell and hooked up to the ESP board, and it is currently plugged into my laptop, but it does not have to be. It works even when it's plugged into another power source. I have an extension cord over there, which is accurate. So see that it's at 3 now, and then we can see that she gets in. And the weight goes up, and now our counter is at 4. And this is essentially how it works. It just keeps going so she can get out again. And the pressure of her pushing down does not trip it again. And then if she gets back in, we are now at 5. And if I open up over here, we can see the email history. It sends an email at the start of the running period. So whenever it's plugged in, it sends just a confirmation like your weight sensor is running. Then we can see an email from earlier, an example, and then that sent at 9:23 when I was doing some testing, but the litter box was used 2 times. So that weight sensor was triggered 2 times.
Out of the pH sensor that's safe for water, you have a nice chlorinated system. So right now, since it's in vinegar, that tells you it's in a warning level of 6.3. And then bam, you need to add more water to reach to that level. Now next is the water pump. This will cycle every 10 minutes currently. Let's see, now we're back to the breadboard. Since now the pH, whenever there's a change in pH or temperature, each color will tell you which areas.
We are showing a light. Now the color is like yellowish, and the color will change with the VOC value change. If the air quality is good, then it will show green color, and if the air quality is bad, there's maybe a lot of pollutants or organic compounds around, the color will become red, and on top of the ROM, you can see the color change to red immediately.
I'm going to start by showing you that my current state of my board or my touchscreen is that there is a red box, which means there is no call being placed right now. You can see that there's no car crash detected. So I'm going to take my board and I'm going to make a collision. You can see that there's been a crash detected, the call was started, and the box has gone green. And I'm going to show you that I had a right collision on my board. I'm then going to go back to the board and I am going to end the call. They would press start call and they would place their fingerprint on the reader, and then it will place a call. The call will not be placed without a fingerprint. It will time out. This is for security purposes, that somebody cannot just randomly call emergency services. So you can see that my BLE board is projecting a Bluetooth signal, and it's called Kennedy. You see that the data comes through to the phone. So you see the location of the car, the type of car, the direction of the car.
So I have here the ESP32 connected to the ultrasonic sensor here. So this ultrasonic sensor will sense this one's supposed to be the garbage or the dumpster to measure the distance. So first I'm gonna measure it empty. So I'm gonna run the code. It will be connecting through the garbage can. So now it will close. So now it showed that the dumpster is full here. So here I have the email that's received. The dumpster garbage can is almost full, and we have to send someone to empty it. was received just now, 0 minutes ago. Automatic.
So this is the final project. On the left is the alarm receiver. So when this receives a signal through the HC12, it starts the piezo alarm here, and it sends a signal to the classifier if this push button is pushed to turn off the alarm here and tell the classifier to begin classifying again. So this is always listening. If it hears the word help, it sends a signal to activate the alarm, and this then goes into a waiting mode, waiting for the button here to be pushed. When this button is pushed right here, we'll turn off the alarm and begin the classification again. So we're going to turn on the serial monitor and start classifying. Help! So it's beeping, and it's going to keep beeping until I press the button, press and hold. It goes back to listening for help! Help! There we go. And press and hold.
Okay, I'm going to sense hydrogen using this combustible gas sensor and ESP32 board, and I'm using a Blink app to monitor the changing gas level live change, and 2% hydrogen is not combustible, so we see a tiny change. We are applying 2% hydrogen, and okay, in the screen here, the laptop screen, we can see this level goes up